Alright, you are welcome to Davetuts Academy, and today what we want to be looking at is the detailed solution to all the questions from 2018 WAEC Further Maths Theory question paper from the May June exam. Now, for your information, this video is not only useful for those who are preparing for further mathematics. For example, the JAMB UTME exam is strictly based on further mathematics, so what we are calling further maths eventually will come to become ordinary maths. So if you are preparing for any of your exams, JAMB UTME, GED, GCSE, IGCSE, you can come over here and learn. Let's learn the rudiments of how to tackle these questions. Let's be equipped so that academic excellence can be your portion. Now, for the benefit of the students out there, there is the workbook for this particular question that have been prepared by Davetuts Academy. And to access it, all you need to do is to click on the link that is included in the description below, and you will have access to all of the solutions. Now, the aim of this is for you to also go ahead and work on your own. From the workbook, you can attempt the question yourself, and subsequently you can look at the solution that is presented by Davetuts Academy. And if you are still having some gray area, all you need to do is to go back to the video, watch them, so that you can have the best preparation for your exams. Now, our work is going to be quite lengthy, but I don't want you to fret. Let's just embark on the journey together. For our fresh viewers, you are welcome to the channel. All we want you to do is that we are desiring that you get academic excellence in all your STEM subjects. And if you are yet to subscribe, click on the subscription icon, click on the notification icon, so that you can have access to all of our resources as we upload them. So without much ado, let's go ahead and solve our questions. Now, question number 1 for WAEC 2018 Further Maths Theory paper. Here, we are given a matrix, and the determinant of the matrix is given as minus 24 with variable x featuring in the matrix, and we are asked to find the value of x from the determinant of that matrix. To solve this, we need to know that whenever we are solving for the determinants, we will first take the first value in the first row and the first column, we cross out the row and the column, and then we cross multiply the leading diagonal and subtract the other diagonal from it, as I'm going to be showing here. So we have x minus 3, then the product of the leading diagonal 2 and 6 minus x, minus the product of the other diagonal, which is 2 and minus 4. And then with this first entry, we can go on to the second entry. Now, some people make it a point of duty to use the second column, while some people make use of the second row. But here, I would prefer to use the second column, so minus 4. And then if I cross out the row and the column, I will notice that my cross multiplication will involve these other entries as shown. But I need to assign my sign, and here the second column will take a negative, so I have minus 4 into bracket the product of the leading diagonal 5 multiplied by 6 minus x, minus the product of the other diagonal, which is 2 multiplied by 2. Then with this, I will now add the third input in my third column. Now this is 3, and if I block out the row and column, I will have 5 multiplied by minus 4 and 2 multiplied by 2. So I have 3 into 5 multiplied by minus 4 minus 2 multiplied by 2. All this is the expression of the determinant, and we are told that it is equal to minus 24. So if you are to expand this bracket, what we need to be careful of is, in expanding our bracket, we don't make any mistake with respect to the signs. So like here, we have x minus 3. If you are to open the bracket, this will be 12 minus 2x. Now, negative numbers multiplying each other will be positive, so that will be plus 8. Then the negative number multiplied by another negative number again, plus 4 into bracket 30 minus 5x minus 4 plus 3 into bracket 5 multiplied by minus 4 is minus 20, minus 2 times 2 is 4. Everything is equal to minus 24. Now, if you are to look at this and try and simplify a little with what we are seeing, we are going to be noticing that our x minus 3 will be multiplying 12 and 8 is 20 minus 2x plus 4 into 30 minus 4 is 26 minus 5x plus 3 into minus 20 minus 4 is minus 24, and everything is equal to minus 24. Now, for the first entry, we are going to multiply these two values that we are having, so that we have 20x minus 2x squared minus 3 times 20 is minus 60, minus 3 times minus 2x will be plus, negative numbers will be plus 6x, then plus 24 times 6, 24 times 6 is 104, so we have 104. Now, 4 times minus 5 will be minus 20x, minus 24 times 3 is minus 72 is equal to, now for this minus 24, let's bring it to the left hand side so that we have plus 24 is equal to 0. So here we can bring out for each powers of x, let's write them out. We have minus 2x squared, and then for the x we have 20x plus 6x minus 20x. So interestingly, we are saying that the 20x we knock out each other. So for the constant, we have 60 minus 60 plus 104 minus 72 plus 24 is equal to 0. So that means this will give us minus 2x squared plus 6x. Now, if you are to sum all this, we have minus 60 plus 104 minus 72 plus 24. That will give us minus 4 is equal to 0. Now, I can just divide all through by 6 by minus 2, because all of them, they are divisible by 2. So, everything over minus 2, minus 2, minus 2. And now, minus 2 will cancel out minus 2. So, we have x squared. Now, 6x divided by minus 2 is minus 3x. And minus 4 divided by minus 2 will be plus 2, because the negative will also cancel out. So, here we have this quadratic equation that we can try and look for the product and the sum, so that we can input here. Now, if you have 2x squared and 3x, we are looking for two numbers that we can multiply to get 2x squared. If we notice minus 2x and minus x, negative numbers will cancel out, so that we have 2x squared. Then if we are to add minus 2x and minus x, we will see that it will also give us minus 3x. And just like that, we have x squared minus x minus 2x plus 2 is equal to 0. Now, moving on from here, we can bring out the common factor. X is common in the 2. X into x minus 1 minus 2 into x minus 1. Now, noticing this, you see that when you say minus 2 times x, that will be minus 2x. And minus 2 times minus 1, that will be plus 2. So, we are on track. And with this, we can bring in our factors. That will be x minus 2 into x minus 1 is equal to 0. Such that x from this, x is equal to 2 or x is equal to 1. And that is what we are asked to find in our question. And that is all about question number 1 in our further math question. Now, our question number 2, we are given that log 3x minus 3 log x3 plus 2 is equal to 0. And we are asked to find the values of x. Now, looking at this question, we need to note some simple rules of logarithm that we can make use of. Like here, we have log 3x and log x3. But one of the rules of logarithm is telling us that log 3x is equal to the same as 1 over log x3. So these are inverse of one another. So if you want to apply this, we can see that our equation will become log 3x minus 3 over log 3x plus 2 is equal to 0. So applying that rule of logarithm had helped us to have only an unknown that we can call p. Let's say p is log 3x. So now in this equation, we can say we have p minus 3 over p plus 2 is equal to 0. And if we take the LCM as p, now we will have it as p square minus 3 plus 2p is equal to 0, or we can say 0 over 1. So that if you cross multiply, we have p square minus 3 plus 2p is equal to 0. Now, if you are just to rearrange, because this is almost looking like quadratic equation already, it is quadratic equation actually. So if you are to arrange it appropriately, we can say p square plus 2p minus 3 is equal to 0. So here, we are looking for two numbers that we can multiply to give minus 3p square, and when we add them, it will be 2p. So now, if you are to look critically, we will notice that if you multiply 3p and minus p, that will give us 3 times minus 1 is minus 3, p times p is p square, that's right. Then if we add them, 3p and minus p will be 3p minus p, which is 2p. So we can have our factors already that we can get from these, such that we can write our equation and say p square, now it will be plus 3p minus p minus 3 is equal to 0, such that if we bring out p from the first two entities, p from the first, it will be p into p plus 3, then you say minus 1, the other will also be plus 3. Now, if you are noticing, minus 1 multiplied by p will be minus p, minus 1 multiplied by 3 will be minus 3. So, we are on track. And this will give us p minus 1 into brackets p plus 3 is equal to 0, such that p is equal to 1 or p is equal to minus 3. But notice that nobody asks us to find the value of p. We are the one that introduced p as log 3x. And so if you are to reverse back to say log 3x, which is p, is equal to 1, here the rule of logarithm stipulates that our x will now be the 3, which is the base, raised to power 1. And like this, x will be 3. Or if you are to look at the other value, or we can say log 3x is equal to minus 3. And using the same principle, that means x will be 3x raised to power minus 3. And from the law of indices, what we notice is that this will yield x is equal to 1 over 3 raised to power 3. And we know 3 raised to power 3 is 3 times 3, 9 times 3, 27, 1 over 27. Now, question number 3 from our further maths WAEC 2018 past question. We are asked to use the substitution u is equal to x minus 2, and we are to rewrite this expression in terms of u. Now, from there we can say u is equal to x minus 2. That means x is equal to u plus 2. So wherever we see x in the expression that we are given, we can use u plus 2 in place of x. So that means we have u plus 2 raised to power 3 plus 5 divided by, now x minus 2 is the same as u, so we have divided by u over 4. Now we have u plus 2 raised to power 3, and to expand, I'm going to be making use of the Pascal Triangle. The Pascal Triangle to get the coefficient of the two entities u and 2. And from the Pascal Triangle, when we have a power of 1, the coefficient is only 1 and 1. Power of 2, we have 1, 2, and 1. And power of 3, we have 1, 3, 3, 1. These are gotten by adding the two previous coefficients. Like here, we have 1 plus 2 will be 3, 2 plus 1 will be 3, and then 1 will be at the extreme. That means we have u raised to power 3 multiplied by 2 raised to power 0. I will explain that. Plus, now we have 3 u raised to power 2 multiplied by 2 raised to power 1, plus again the second 3 multiplied by u raised to power 1 multiplied by 2 raised to power 2, and then we have 1 u raised to power 0 multiplied by 2 raised to power 3. Let me clear the board and then I will explain this. What you need to note, apart from using Pascal's triangle to get the coefficient, here for the two entities u and 2, the powers of u, which is the first entity, is starting from the highest power, which is 3, and then it is descending down the line, while the power of the second entity 2 is ascending from 0 up till the highest power, which is 3. And so that is how we do expansion. Even in binomial expansion, the same thing is what we make use of. So we have 3, 2, 1, 0 and 0, 1, 2, 3. So now we can go ahead to open our brackets. So we have 2 raised to power 0 is 1. So we have u raised to power 3 plus 2 raised to power 1 is 2 times 3 is 6. We have 6u square plus 2 raised to power 2 is 4 times 3 is 12u. Then we have u raised to power 0 is 1 and 2 raised to power 3 is 8. Then plus 5, everything divided by u raised to power 4. Now this will give us u raised to power 3 plus 6u square plus 12u. 8 plus 5 is 13, all divided by u raised to power 4. And like that, we have gotten the first question 3a that we are asked to find. We've expressed that expression in terms of u. And now in the second question, we are asked to express s cubed plus 5 over x minus 2 raised to power 4 in partial fractions. What do we mean when we say we want to express something in partial fractions? Partial fractions is a means of expressing our whatever we are working with in progressive powers of that variable. We express this, we write the expression in progressive power of the variable just as it was shown, and that means here we want to write in terms of x, and then it will be that we'll be using this u and reverting back to x. We'll be using u, but now we want to express it back in x. So we have s cubed plus 5 over x minus 2 raised to power 4 will be u3 over u4 plus 6u square over u4 plus 12u over u raised to power 4 plus 13 over u raised to power 4. What I'm doing is I'm splitting each of the entities so that I can have the format of the partial fraction, and this will be 1 over u plus 6 over u square plus 12 over u cube plus 13 over u4. And now if you're observant, you will discover that we are having the denominator in increasing powers of u, but we know that u is x minus 2. So if we substitute that, what we are asked to find will come out as 1 over x minus 2 plus 6 over x minus 2 all square plus 12 over x minus 2 raised to power 3 plus 13 over x minus 2 raised to power 4. And that had given our expression exactly in partial fractions as we are asked to do. Here, question number 4 from WAEC 2018 further mathematics theory paper. We ask that the sum of the first 12 terms of an arithmetic progression and AP is 168. The third term is 7, and we're asked to find the common difference and the first term. Now, there is a general formula for getting the sum of the first n terms, and it's given as n over 2 into 2a plus n minus 1d as written, where a is the first term and d is the common difference. So now, when we are told that the first 12 terms is 168, that means the n is 12, the number of terms, and x12 is 12 over 2 into 2a plus n minus 1d. n is 12, so 12 minus 1d. So x12 we have been given to be 168, over 2 is 6 into 2a plus, now we have 12 minus 1, 11d, and all this is equal to 168. This is 168. 6 can be used to divide 168, and we'll have 28. That will be 28, such that we have 2a plus 11d is equal to 28. And we can call this equation 1 while we'll try and interpret the other hint that we are given in the question. And the other hint is saying that the third term is 7. There is also a general formula for the nth term of an AP. The nth term of an AP is given as Tn is equal to a plus n minus 1d. A is the first term, and n is the number of terms, and d is the common difference. So here we have been told that the third term is 7. So 7 is equal to a plus 3 minus 1d. And that means we have a plus 2d is equal to 7. And we can call this equation 2. So we have two simultaneous equations that we can solve by any method we like. I will be employing the substitution method to try and solve this, so that we can get the value of a and d. So we have 2a plus 11d is 28, and we have a plus 2d is equal to 7. Now, from our equation 2, if we are looking at this equation 2, we can express a in terms of d, so that we can use that expression in the first equation. So from equation 2, our a is equal to 7 minus 2d. And if we are to use this in the first equation and substitute for a, we are going to have 2 into 7 minus 2d plus 11d is equal to 28. Opening that bracket, we yield 14 minus 4d plus 11d is 28. Minus 4d plus 11d is 7d. When 14 crosses to the other side, we have 28 minus 14, which is 14, such that d will be 14 over 7, and that is 2. And already we know that a plus 2d is equal to 7. So you can say that a is 7 minus 2d, and that is 7 minus 2 times 2, which is 7 minus 4, and that is 3. And as easy like that, in our further maths question, the questions we are asked to solve, we have solved. We've found the common difference. We found the first term, and our question is done and dusted. But as an additional hint, sometimes we may be asked to find the expression for maybe the nth term, or the expression for the sum of the first n terms. What we just need to do is, in the general formula, for example, we want to find the general nth term for this AP, we can say Tn is a plus n minus 1d. And since we know a is 3 and d is 2, we can expand this to be 3 plus 2n minus 2, which is 2n plus 1. And using 2n plus 1 for any n term, we don't need to plug in the a or d again. We can get that. And in the same manner, we can also use this to find the sum of the first nth term. We're asked to calculate the Spearman's rank correlation coefficient for the decision of two panel of judges. Now, the question is, what do we use Spearman's rank correlation for? It's used to determine if two variables are monotonic, meaning that as one set of variables, as it increases, is the other also increasing in the same manner? Or if one set of variables, one set of ranking is decreasing, is the other ranking, is it also decreasing? So the Spearman's rank correlation is a measure of the monotonic nature of two variables. Here, it is the ranking of oil that we are given. And to get this, there is a general formula that is normally employed, especially since here in our ranking we don't have the repetitions. The Spearman's rank correlation is given as 1 minus 6 sigma d square over n into n square minus 1, where d, as noted in the equation, is the difference between the ranking that we are talking about. This is the difference in ranking between the variables that we are talking about, and then n is the number of entries that we are talking about, is the number of parameters that are being ranked as given in whatever question we'll be trying to solve. So here we are going to generate a set of values from the information that we are given. So we have the oil type, we have the rank X, we have the rank Y. We are going to find the value of D, then we are going to find the value of D square. So if you are to come up with a table, let me do that, then we'll come back. Rank X, rank Y, then the difference between the two is Rx minus Ry, then the square of the difference. So I'll go ahead and populate the table and then come back to finish up with the lecture. So here, 8 minus 6 is 2, 5 minus 3 is 2, 1 minus 4 minus 3, 7 minus 8 is minus 1, 6 minus 7 is minus 1, 4 minus 2 is 2. And then, as a rule of thumb, so that we'll check if you are not making any mistake, if we sum the difference, it should normally give 0. Like here, we have 2 plus 2 is 4, minus 3 is 1, plus minus 1 is 0, minus 3 is minus 3, minus 1 is minus 4, plus 2 minus 2 plus 2, 0. So the sum of D must be 0 to show that we are on track. And we can go ahead to find D square. And the sum of D square, we can also find to input into our equation for the Spearman's rank correlation coefficient. Now, the sum of this D square, let's bring in our calculator. We have 4 plus 4 plus 9 plus 1 plus 9 plus 1 plus 4 and plus 4. That's 36. So we have 1 minus 6 multiplied by 36 over our n is 8. So 8 into 8 square minus 1. And that will be 1 minus, we can 6 times 36 over 8 into 8 square is 64, 64 minus 1 is 63. So we can cut, let's cut with 4 in 36 is 9, 4 in 8 is 2, 2 in 8, 1, 2 in 6, 3. So we have 1 minus 27 over 63. And if you find the LCM, that will yield, that will be 36 over 63. 3 can go in both numerator and denominator, and we'll add that is 12 over 21. So that is the correlation coefficient that we are asked to find. Here in this question, we are told that the probability that Kunle solves a particular question is 1 over 3, while that of Tayo is 1 over 5. If both of them attempt the question, we are to find the probability that only one of them will solve the question. Only one of them. We need to be able to interpret this question correctly. Now, the probability that Kunle solves is 1 over 3. So, the probability that Kunle fails will be 1, let's say, probability of K prime is 1 minus 1 over 3. And that is 2 over 3. And in the same way, the probability that Tayo will solve is 1 over 5. So, the probability that Tayo will fail, which we can call probability of Tayo prime, T prime, is 1 minus 1 over 5. And that is 4 over 5. Now, we are asked to find the probability that only one of them will solve the question. Now, we have two people attempting some question, and only one of them will solve. That means that is either Kunle solves the question, and when Kunle gets it, then that means that Tayo fails, meaning that only one solves, or Kunle will fail, he will fail the question, while Tayo will solve it. Now, this interpretation is a very good indication of how best we can go about solving our question. Instead of using while, we can use and. We can use and, meaning that either Kunle solve and Tayo fails, or either Kunle fails and Tayo solves. And in probability, when we're using and, we are talking about multiplication. When we're using or, we are talking about addition. So, what we're asked to find, the probability, will mean that we have Kunle solves 1 over 3 multiplied by Tayo fails 4 over 5 plus Kunle fails 2 over 3 multiplied by Tayo solves, which is 1 over 5. So, if you are to evaluate that, that will be 4 over 15 plus 2 over 15. Right now we had that will be 6 over 15, which you can divide by 3 to have 2 over 5. That is the solution to question number 6a. Okay? So now we can go to question number 6b. A committee of 8 is to be chosen from 10 persons. In how many ways can this be done if there is no restriction? If there is no restriction, we want to pick 8 out of 10. So without restriction, this is a question in permutation and combination. And here is only a matter of combination. We want to pick 8 out of 10. And the number of ways to generally choose 8 out of 10 is given by the combination formula 10 combination 8, which will be 10 factorial over 10 minus 8 factorial multiplied by 8 factorial. This is directly coming from the general equation that n combination r is n factorial over n minus r factorial r factorial. So, if you are to try and evaluate this, what we are going to get is 10 times 9 times 8 factorial. I'm not proceeding because I know it will cut out the other 8 over 2 factorial multiplied by 8 factorial. So the 8 factorials will cut out so that we have 10 times 9 over 2 factorial is 2 times 1. 2 will cut 10 in 5. So we have 5 times 9, which is 45 ways of selection. Now, with the calculator, we can actually press combination from the calculator to check if you are not making any mistake. So when we press our shift divided is the sign for the combination. So in this case, we can say we want to evaluate 10 combination 8. That is equal to 45. And just like that, our question number 6 is totally solved. So here, our question number 7 from 2018 for the mathematics core paper. We have a question on complex numbers, but it's only algebra processes that we are going to be carrying out on these complex numbers. Now, we are given 3 complex numbers, m, n, and p, and we're asked to find 4m plus 2n minus 3p. Now, it's as simple as you can get it. All we need to do is just to substitute the values of m, n, and p in this particular expression. And what we are going to be having is 4 into all of m plus 2 into all of n minus 3 into all of p. And if you are to try and evaluate that, we can just open up our brackets so that we will have 12i minus 8j plus 2 times 2 is 4i. 2 times 3j will be 6j. Then now, minus 3 and minus I will be plus 3i, and 3 multiplied by 6j will be minus 18j. Such that by the time we are collecting like terms, if you are to collect like terms, we have 12i plus 4i plus 3i, now minus 8j plus 6j minus 18j. And now if you are to just sum all this, sum the like terms, we are going to have 19i minus from 20j. And that is a solution to question number 7 from WAEC 2018 further maths theory paper. Okay, our question number 8 now. We are given that a body of mass 20 kg moving with a velocity of 80 meters per second collides with another body of mass 30 kilograms moving with a velocity of 50 meters per second. Now, the two bodies are assumed to move together in the same direction after the collision. So we have to find the common velocity. If they moved in the same direction before collision, then in opposite direction before collision. Now, for the first part, when they are moving in the same direction before collision, so we have two case scenarios. Before the collision, we have 20 kilograms moving with initial velocity of 80 meters per second, and then the 30 kilogram body moving with an initial velocity of 50 meters per second. Now, we are told they are moving in the same direction. So if we take our direction to be the positive body, x-axis, both of them will be pointing towards that positive x. Now, after collision, we are told that they move in the same direction after collision. So we can have the two bodies, the 20 kilogram body and the 30 kilogram body, and both of them, they will move with a common velocity, meaning that the same velocity after collision. Now, with this analysis, we can use the principle of conservation of momentum, saying that the momentum before and the momentum after, they are equal. And here, the momentum before is the product of the mass and the velocity of the two bodies, and then this will be 20 times 80 plus the other body is 30 times 50, and is equals to the sum of the masses of the two, 20 plus 30 multiplied by their common velocity. So that will give us 1,600 plus 1,500 is equal to 50V. And if we sum the left-hand side, that will give us 3,100 is equal to 50V, such that our V is 3,100 divided by 50. The 0 will cut out, and that will leave us with, let's see, 310 divided by 50 divided by 5. That is 62 meters per second. So that is the final velocity if the objects are moving in the same direction before collision. So if you are to go to our question number B, we are now told that if they are moving in the opposite direction before collision, we have to find their common velocity after the collision. So again, if you are to analyze this, before collision, we have the 20 kilogram body and the 30 kilogram body moving in opposite direction. So we have 20 kilogram. Let's say that is moving in the positive x-axis. We have 80 meters per second. And then we have the 30 kilogram body moving in the opposite direction. So opposite direction here will be opposite to the direction of the previous one. So here we have 50 meters per second. And then after collision, now we don't know, maybe they will be moving towards the right or towards the left, but we just assume one. And if our final mass is negative, then we know our assumed direction is wrong. So we have the two bodies, but now moving with a common velocity, let's say still in the positive x direction. So by principle of conservation of momentum, if you are to evaluate this, we'll have the first mass multiplied by the velocity plus the second mass multiplied by the velocity will be the sum of the masses multiplied by the common velocity. So here our M1 is 20 kilogram multiplied by 80. Now the second mass is 30 kilogram, but our velocity is in the opposite direction, so we use negative, minus 50 meters per second. And this will now be equal to the sum of the masses, 20 plus 30 multiplied by the velocity after collision. That will give us, that will be 1,600. Now 30 multiplied by minus 50 will be minus 1,500, which is equal to 50V. If you subtract the left hand side, we will have 100 is equal to 50V, such that our V will be 100 divided by 50, and that is equal to 2 meters per second. Now, that is the velocity of the two objects, their common velocity when they move in opposite direction before collision. What we need to note as a rule of thumb is that assuming that the velocity we got eventually is a negative number, if we get like say v is equal to minus 2 meters per second, that is only an indication that the direction we choose for the object initially was wrong. Then we should reverse the direction. Being a vector quantity, that means that the velocity it has another direction but the same magnitude. We just need to take note of this, and in that case, this final velocity will be in the other direction, and we can tag it as v. So here we have this question that we are given 3 points that a circle was drawn through center, and we have to find the coordinates of the center of the circle. We have to evaluate the radius of the circle, and ultimately to write out the equation of the circle. Now, if you consider our Cartesian plane and draw a circle on it, we can take the coordinates of the center of the circle on the x-axis and on the y-axis as shown in the diagram. On the y-axis and x-axis, on the x we can call it A, and on the y-axis we can call it B. Now, the circle will have a radius r that is drawn from the center of the circle to any point on the circumference. And with this, there is a general format of the equation of a circle that is well accepted. It's called the standard circle equation, and the standard circle equation was derived from this diagram. Without going through the details of derivation, it is given as x working minus a all square plus y minus b all square is equal to the radius square. Now, this is a standard circle equation, but sometimes working with the questions that we are given, we may not have the opportunity to really express our equation in this. So if you go ahead to expand the brackets, what we are going to get from this standard circle equation is s square. Now we have ax in two places, so we have minus 2ax. Then when the negative multiply each other, we have plus a square. And the same thing will be applicable for y square minus 2by plus b square all is equal to r square. Now, from the left hand side, if you are to put the x and y variables together, we can find s square plus y square minus 2ax minus 2by, then plus a square plus b square. Now, if we take the radius to the left hand side, we have minus r square all is equal to 0. Now, if you're observant, already we are generating another form of the equation. So, if we take the constant a square, b square, and r square and denote as z, and instead of using minus 2a and minus 2b, if we revert that, we can find another format of the circle equation, which many times we also find useful, and that is given as s square plus y square plus 2fx plus 2gy. Now, instead of all this a square, b square minus z, we have plus z is equal to 0. This is noted as the general form of the circle equation. Now, having this understanding, we'll be able to go ahead with our questions and try and see what format will be best, will be most suitable for us, and we can answer our question from WAEC Further Mathematics 2018 theory paper. So now, in this question, we are given that there are 3 points that the circle was drawn through, but if we note the general form of the circle equation, that general form that we have been given, that we just highlighted not too long ago, we can say s square plus y square plus 2fx plus 2gy plus z is equal to 0. Now, for this that we are given, we can take each of those points and substitute the value of x and y into this general equation of the circle, and that will give us some set of equations that we can try and solve. So if you are to take, in the first case, for 3, 2, x is 3, y is 2. If you substitute in this equation, we are going to be having 3 square plus 2 square plus 2f of x, and x is now 3 and f is there, plus 2. Now y is 2 multiplied by g plus z is equal to 0. And if you evaluate this, that will give us 9 plus 4 plus 6f plus 4g, which is 2 times 2, plus z is equal to 0. Now, we can have this as 6f plus 4g plus z. When 9 and 4 move to the other side, they become minus 13. And this we can call equation 1. Now, moving on from there, for the point minus 1 and minus 2, for the point minus 1 and minus 2, if we substitute this value into our general equation also, and we use minus 1 for x and minus 2 for y, what we are going to get eventually, if we substitute just like that, we are going to have 1 plus 4, 2 times minus 1 is minus 2, then 2 times minus 2 is minus 4g. That will give us minus 4g plus z is equal to 0. Such that here we can have minus 2f minus 4g plus z is equal to 1 plus 4 is 5. When we move to the right hand side, it becomes minus 5. And for me, I like to work with positive values, so I will rather multiply all through by minus 1. So we have 2f plus 4g minus z is equal to 5. I can call this equation 2. Now that's equation 2. And in the third case, for 5 comma minus 4, for 5 comma minus 4, I can go ahead and that will be 5 square plus minus 4 square plus 2 into 5 multiplied by f plus 2 into minus 4 multiplied by g plus z is equal to 0. And that will yield 25 minus 4 square is 16. 2 times 5 is 10, so I have plus 10f. 2 times minus 8 is minus 4 is minus 8. Then I have plus z is 0. Now, 10f minus 8g plus z, 25 plus 16 will be 41. When we move to the right hand side, will be minus 41. And this I can call equation 3. Now, interestingly, from trying to evaluate question on the circle, we are now being led to a simultaneous equation in 3 variables. And having a simultaneous equation in 3 variables, how do we go about to solve that? That's what we are going to be embarking upon next. And now, after I succeed in evaluating that, I will check with the calculator to check that I am on track and I'm not missing my questions. So we want to find the variables f, g, and z from this simultaneous equation in 3 variables. As you can see, quite a lot of things are there for us to learn. Like here, we can also learn about solving simultaneous equation in 3 variables. And that's why our advocacy here is always that we can easily study together, we can learn together. And that's why we advocate that go ahead to subscribe to the channel, click on the notification icon, share the videos, like them, leave your comments in the section below, and let us learn together how best we can prepare you for your academic excellence. That's what Davetuts Academy is all about, and it will be a plus for you to actually be part of this journey together. So here we have our 3 equations, And when we are solving for simultaneous equation in 3 variables, there are quite a number of ways. What I want to do is I want to eliminate one of the variables. So if I had equation 1 and 2, because I want to eliminate z, I'm going to have 6f plus 2f is 8f, 4g and 4g is 8g. The z plus z minus z will be 0, then minus 13 plus 5 will be minus 8. Now, of course, 8 is common all through. If I divide through by 8, I'm going to have here, I'm going to have f plus g is equal to minus 1. This I can call my equation 4. Let me call that equation 4. Then again, if I look at equations 2 and 3, I can also eliminate z again if I had both equations. So equations 2 and 3 being added together, I have 2f and 10f, and if I add them together, that will be 12f, then plus 4g and minus 8g, that will be minus 4g. The z will cancel out, then 5 plus minus 41 will be minus 36. Again, looking at this, I can divide all through by 4 to have 3f minus g is equals to minus 9. This I can call my equation 5. Now, looking at equations 4 and 5, we can see that if we also add them, g will be eliminated out such that I can have f and easily solve for my f. The g's I have plus g and minus g. If I had the 2, that will eliminate the g so that I can solve for f. So equation 4 plus equation 5 will yield f plus 3f will be 4f, then g will cancel out, then minus 1 plus minus 9 will be minus 10, such that my f is minus 10 over 4, and dividing by 2, I have minus 5 over 2. So I have the value of f, that is solved, f is resolved. Now, in one of the previous equations, either equation 4 or 5, I can substitute the value of f so that I can have g. So using equation 4, f plus g is equal to minus 1, and f is minus 5 over 2, meaning that g will be minus 1 minus f. That's minus 1 minus 5 over 2. The negative, we multiply each other to give minus 1 plus 5 over 2. And if I find the LCM, that will be minus 2 plus 5, such that g is 3 over 2. Good. So I've obtained g to be 3 over 2. I've obtained f to be minus 5 over 2. I can use any of equations 1, 2, or 3 and substitute for the values of f and g to get the value of z. So if I'm using equation 2, now 2f plus 4g minus z is equal to 5. Meaning that if I substitute my values, I will have 2 into minus 5 over 2 plus 4 into 3 over 2 minus z, which I'm looking for, is equal to 5. So now I can cancel out the 2 to have minus 5. 2 times 3 is 6, plus 6 minus z is equal to 5. And if I move minus 5 and plus 6 will be 1, so minus z will be 5 plus 5 minus 6, which is 10 minus 6 is 4, and that means that my z, therefore z is minus 4. So with these 3 equations, I've used elimination method to find the values of my 3 variables. I want to ensure that I got my values right. So I will use my Casio FS calculator to also confirm, to note that all these that I've gotten, they're actually the correct values as expected of me. I got f to be minus 5 over 2, g to be 3 over 2, and then z to be minus 4. So I'll bring in my calculator, slot in these 3 equations, and check if my solution to these simultaneous questions is actually correct. So here, if I go to mode, I want to work on equation, that is 5. And then the format of my equation, if you look at it, is corresponding to 2. That's 3 variables, x, y, and z. So here, it's being put in a matrix format. The instead of having x, y, and z, I'm using f, g, and z now. So 6f, 4g, and z, 1z, then d is minus 13. Second equation, I have 2f, 4g, I have 4, then minus z, I have minus 1, and then is equal to 5. Then in the third equation, I have 10f, 10, I have minus 8g, minus 8, then z, that's just 1, then is equal to minus 41. Alright. Now if I press equal to, now my x, which is the variable the calculator is using, is minus 5 over 2, y is 3 over 2, and z is minus 4. So I'm actually good to go with the values I obtained. I can move ahead to try and solve my questions as asked for the circle. So now going back to the equation that I started with. So if I'm to recall the general format of the equation I'm using, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0. Now, I've gotten the values of f, g, and z. If you recollect, our f, we have f to be minus 5 over 2, g is 3 over 2, and z was obtained as minus 4. Okay, so if I'm to plug in these values into this general format of the equation of the circle, let me go ahead and do that. So I have x squared plus y squared plus 2. My f is minus 5 over 2 multiplied by x plus 2. My g is 3 over 2 of y plus z is minus 4, that's equal to 0. Now, because of the standard form that we are actually also looking for, we can notice that we can actually go ahead to do the operation of completing the square on this particular expression. Now, again, our question is leading us to completing the square, and you don't need to be frustrated, you don't need to be agitated at all. We can actually take this expression and use completing the square to bring out some very cogent equations, so that we have x squared plus 2 into minus 5 over 2 x plus y squared plus 2 into 3 over 2y. Now we have plus minus 4 is equal to 0. Now I'm deliberate not to cut out like this because I want to try and complete my square. Now, generally, when we are having a factor, let's try and explain that. Generally, when we're having, let's say, x plus minus 5 over 2, and we are squaring all this. Now, let's try and expand this. This will be x plus minus 5 over 2 multiplied by x plus minus 5 over 2. Now, if you open this bracket, that will be x multiplied by x squared, and x plus multiplied by minus 5 over 2 in two places. That will be plus 2 into minus 5 over 2x. Okay. Then minus 5 over 2 multiplied by minus 5 over 2 will be minus 5 over 2 all square. Now, we need to look at this expression critically, and we'll evaluate that. What we are having in our equation that we are coming from is x squared plus 2 into minus 5 over 2x. And that will be equal to, now, the left-hand side, if you take minus 5 over 2 squared to the left-hand side, we have x plus minus 5 over 2, everything all square, minus 5 over 2 square. Now, I took the time to explain this because I'm going to substitute these values into this equation, and we can do the same thing for y, such that from there, what we are going to be having is, we'll have, instead of writing x squared plus 2 into bracket minus 5 over 2x, we are going to write this expression on the right hand side. So, if you are to do that, what we have is x plus minus 5 over 2, everything all square, minus 5 over 2 squared. The same thing for y will give us y plus 3 over 2 all squared minus 3 over 2 squared plus minus 4. So, this we can go ahead to say is x minus 5 over 2 all square plus y plus 3 over 2 all square. Now, minus 5 over 2 all square will be 25 over 4. Then minus 3 over 2 all square will be 9 over 4. Then we have minus 4, all is equal to 0. And I'm doing this because I want to revert back to the standard form of the circle equation so that we can get the coordinates and the radius of the circle. So having this, we can clear our board and write out our equation as desired. So here, that means we have x minus 5 over 2 all constant plus y plus 3 over 2 all square is equal to, when we move all the other constants to the right hand side, 25 over 4 plus 9 over 4 plus, now 4 can be taken as 4 over 1. And so we find the LCM for, we have 25 plus 9 plus 1 in 4 in 4, 4 times 4 is 16. So that will be 25, 9 and 16. That will be 4 and 16. That will be 50 over 4. So that will, 2 will go and we have 25 over 2. Such that our expression for the equation of the circle will be x minus 5 over 2 all square plus y plus 3 over 2 all square, and that's equal to that's 25 over 2. But I want to postulate something. If I say 4 and I have square root of 4 all raised to power 2, that will be 2 raised to power 2, which is equal to 4. So finding the square root and squaring is actually annulling each other. That means I can say this is square root of 25 over 2 all square. It's as if I'm just writing 25 over 2 alone. Now, for this new equation that we have obtained, if we compare to the standard form of the equation of a circle, if you are to compare this to x minus a squared plus y minus b squared is equal to r squared, we can see that our coordinates is easily obtained, our radius is obtained, then the coordinate of the center of the circle will be a comma b, and comparing the two, we can see that minus a is 5 over 2, and our b will be minus 3 over 2. Now, the thing to note is that we may make the mistake to just say 3 over 2. No, it is minus 3 over 2. And from there, the radius is the square root of 25 over 2. And just like that, we have gotten the center of our circle, the coordinates, and the radius of the circle. Now, the equation of the circle, we could as well leave it as what we obtained before, x minus 5 over 2 all square plus y plus 3 over 2 all square is equal to the square root of 25 over 2 all square, or just ordinarily 25 over 2. Either of the two is the same. But interestingly, we can go ahead to expand the bracket, then evaluate, simplify the equation, or from the general format of circle equation that we use, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0, we can also substitute the values of f, g, and z. F is minus 5 over 2, g is 3 over 2, and z is minus 4. We can substitute these values back so that we have x squared plus y squared plus 2f is minus 5 over 2 plus 2, g is 3 over 2 multiplied by y, z is minus 4 equals to 0. And here, if we just cut out the 2's, our equation will come out as x squared plus y squared minus 5x plus 3y minus 4 is equal to 0. And with that, we've been able to evaluate the equation of the circle, the coordinate of the center of the circle, and the radius of the circle. We are having this equation that we're asked to solve, and it's an equation with respect to indices. And here, we are going to be employing the law of indices, and particularly the law we want to note is that when you have a number raised to power the product of two powers, that will be a raised to power m can be a raised to power m first, then all raised to power n. Then a raised to power m plus n is a raised to power m multiplied by a raised to power n. And looking at the equation that we are asked to solve for, if we say we should eliminate 2 raised to power y and say 2 raised to power y is equal to p, we can rewrite this equation to say, using these two laws that we have highlighted above, we can say now we have 2 raised to power 2, which is the one for 7 plus 2, multiplied by 2 raised to power y, all raised to power 3, minus 7. Now, all these expressions, we can have it as 2 raised to power 2 first, then 2 raised to power y raised to power 2, minus 31 multiplied by 2 raised to power y minus 8 is equal to 0. This is writing from the laws that we have highlighted, and by the time we put in our p for 2 raised to power y, this will be 4p raised to power 3 minus 2 raised to power 2 is 4 times 7 is 28p squared. Now minus 31p and minus 8 is equal to 0. And now with this, we have resolved to get a polynomial of degree 3. This is a polynomial of the 3rd degree, and we will need to find a way to solve for this polynomial so that we can find the term of y. Now, there is a factor theorem that we can make use of, and the factor theorem of a polynomial states that if, say, p minus a is a factor of a polynomial, if p minus a is one of the factors of a polynomial, then the function of a will be 0. Meaning that if we input the value of a in the polynomial and we solve it, then that polynomial will be equal to 0. So now, what we normally take is we begin to assume some numbers that we want to slot into the equation such that we will find through the factor theorem that the function of that factor we are looking at is 0. Let's assume that p minus 1 is a factor. Then function of 1, if we want to evaluate it in this polynomial, will be 4 multiplied by 1 raised to power 3 minus 28 times 1 raised to power 2 minus 31 multiplied by 1 minus 8 is equal to, if we say we should evaluate that, let's bring in our calculator. We have 4 x raised to power 3 minus 28 x square, 28x square minus 31x, then minus 8. If you are to calculate when x is 1, now this is minus 63. That means the function of 1 is minus 63. This is equal to minus 63, and that is not equal to 0, meaning that p minus 1 is not a factor. Now, the dilemma we are facing in our exam is we don't have the luxury of time to be taking assumed values again and again so that we want to check. Sometimes working with minus 1 will easily yield what we are looking for. Sometimes working with 1 will easily yield what we are looking for, but we need to work smart. So what I personally advocate for is, let's make use of our calculator to try and solve this polynomial equation. The calculator has a mode that we can use, and if you go to mode, 5 is equation. Then if you look at the 4th entry, that is the entry for solving for a polynomial function of degree 3. So if you put in our values of coefficient, 4, minus 28, minus 31, and then minus 8. Now it's solving and telling us that x1 is 8 minus, and then x2 is minus 1 over 2. Okay, it's only giving us 2 solutions, well, meaning that one of the solutions is being repeated. So here, we already know that, of course, we have 8 and we have minus 1 over 2. So let's assume, since we need to show our workings in our exams, we'll say let's assume that p minus 8 is a factor. Then the function of 8 will be 4 multiplied by 8 raised to power 3 minus 28 multiplied by 8 raised to power 2 minus 31 multiplied by 8 minus 8 will be, now we can bring in our calculator to also evaluate it. And if you want to evaluate that, that will be, let's go back to our normal mode. 4, okay, it's not giving me the option to go back. Let me just work it out. 4 multiplied by 8 raised to 33 plus, okay, minus 28 multiplied by 8 raised to power 2 minus 31 multiplied by 8, then minus 8 is equal to 0. So this, we can say it is 0. And since it is 0, that means p minus 8 that we assume is actually a factor of this polynomial we are trying to solve for. And now, we still need to go ahead and check for the other factors. And because we need to show our workings, that means we will be employing the division of a polynomial. We already know a factor. Now, this is a polynomial of degree 3. So, we have known a factor. P minus 8 is a factor. Then, to get the other factors, we divide our polynomial by p minus 8. So, we'll be doing polynomial division. Now, we need to be smart because already, from using our calculator, we know that the other factor will be x plus 1 over 2 because the calculator evaluated x to be minus 1 over 2. So, working smart had helped us, and we can move on with our calculation. And trying to now evaluate our other factors, let's divide this polynomial by the factor we already know, p minus 8. So, we want to divide 4p raised to power 3 minus 28p squared minus 31p minus 8. We want to divide it by p minus 8. And what we do is we take the first entry, we say p in 4p raised to power 3, that will be 4p squared. 4p squared multiplied by p is 4p raised to power 3. 4p squared multiplied by minus 8 will be minus 32p squared. Now, if we subtract these first two entries, it will be like 28 minus 32. Of course, the 4p raised to power 3 will cancel out. That will be 28 plus 32p squared, which will be 4p squared. And if we bring the other factors down, we'll have this. And when we say p in 4p squared, we have 4p. 4p times p will be 4p squared minus 4p times minus 8 is minus 32p. And if we also subtract, 4p squared will cancel out. We have minus 31p minus 32p. That will be minus 31p plus 32p, which is p. Then we'll bring minus 8 down. Of course, this is p minus 8 in p minus 8 is 1. And there is no remainder for our division. Meaning that 4p squared plus 4p plus 1 is the other, constitute the other factors of the polynomial that we are looking for. So we can conclude and say that we have 4p squared plus 4p plus 1 actually constitutes the other factors of the polynomial. So this is the other factor, And we can still go ahead to factorize this so that we get the set of factors particularly and not just a quadratic equation. So if we want to factorize 4p squared plus 4p plus 1, we can easily do that by saying this is 4p squared plus 2p plus 2p plus 1. And now 2p is common to the first two entries, and that will be 2p into 2p plus 1, then plus 1 into 2p plus 1. And here we have the same factors, 2p plus 1, 2p plus 1. So we can now understand why our calculator gave us just only 2 entries as the factor of the polynomial. So from here, p will be minus 1 over 2 as indicated in our calculator, but minus 1 over 2 is not a real number. This is not a real number, so we can't use that because our question said that we want to evaluate y for a real number. So we can go ahead to say that means our p is 8, and of course 8 is a real number. That means 8 is equal to 2 raised to power y, and that is a real number, such that 2 raised to power y is equal to 8, and we know 8 is 2 raised to power 3. Now, the number bases will cancel out so that y is equal to 3. And this is the solution to what we are asked to do. We are asked to solve for this equation, and our y as a member of the real number is given as 3. So now our question number B, question number 10B, WAEC 2018, further maths, May, June. This is an integration, and we are asked to find the integral of x squared plus 1 all multiplied by x dx. We can rewrite this to say x squared plus 1 raised to power 1 over 2 to cater for that square root. But now we can just use integration by substitution to say let u be x squared plus 1. Then from here, if you differentiate, the u dx will be 2x. Now it will be plus 0 because 1, when you integrate that, when you differentiate, that will be 0, is a constant. Then from du dx is equal to 2x. If we cross multiply and find x dx, you can find x dx to be du over 2. Now, since we are making all this substitution now, we can go back to our original question, and instead of writing integral of x squared plus 1 raised to power half x dx, we can substitute for u and x dx to say this is equal to integral of u raised to power 1 over 2 du over 2. And that will be 1 over 2 integral of u raised to power 1 over 2 du. And now this is simpler for us to solve. And by the time we make that integration, that will be 1 over 2. If we integrate, what we do is we add 1 to the power u 1 over 2 plus 1, and then that new power will be coming to divide our expression as 1 over 2 plus 1 as written, plus constant c, the constant of integration. Now this will be 1 over 2 into half plus 1 will be 3 over 2 over half plus 1 will also be 3 over 2. Now, all plus c. With this, the 2 that is at the base will come up. So we have 2 over 2 into u raised to power 3 over 2 over 3 multiply plus c. And 2 over 2 is 1. So this will give us 1 over 3 multiplied by, now our u originally we know is x squared plus 1 all raised to power 3 over 2 plus c. And this is the solution to the integration question that we are asked to solve. So here in question number 11, WAEC 2018 further mathematics theory paper, we are told that the binomial expansion of 2 minus 1 over 2x raised to power 5 is to be written out in ascending power of x, and then we use the expansion in that question to find the value of 1.99 raised to power 5. Now, there is a general rule of thumb when it comes to working with binomial expansion. Say, for example, we have a plus b raised to power n. What we do when we want to find the binomial expansion is to find the n combination 0 multiplied by a raised to power n, b raised to power 0, and then plus n combination 1, a raised to power n minus 1, b raised to power 1, plus n combination 2, a raised to power n minus 2, b raised to power 2, and on like that. Now, what we need to note is that from the first entry, we are having a raised to the highest power and b raised to 0, and then subsequently the powers of a will be reducing while the powers of b will be increasing. So a start from n to n minus 1 down to 0, b start from 0 to 1, 2, up to n. And then having this as a general expression for the binomial expansion, we can go ahead and say we want to work with our 2 minus x over 2 raised to power 5. In this case, this will be 5 combination 0, 2 raised to power 5 multiplied by minus x raised to power over 2 raised to power 0, plus 5 combination 1, 2 raised to power 4 minus x over 2 raised to power 1, plus 5 combination 2, 2 raised to power 3, we are reducing the power, minus x over 2 raised to power 2, we are increasing the power. Now, the mistake that students normally do is that when we are working with the minus x over 2, we tend to forget the negative sign and we just write x over 2. And right from the beginning, we're already getting our question wrong. So if you continue correctly, the last term will be 5 combination 5, 2 raised to power 0 minus x over 2 raised to power 5. Now, we need to note, how do we find the expression for combination? How do we find the expression for combination when we are working with all this? That's number one. And then any number raised to power 0, we should know that it is 1. So for 5 combination 0, 5 combination 1, 5 combination 2, formula 2, up till 5 combination 5, we can actually find the general formula n combination r to be n factorial over r factorial multiplied by n minus r factorial. And if we plug in these values, we are going to be getting the values of each of those combinations. Like 5 combination 0 will be 5 factorial over 0 factorial 5 minus 0 factorial. Now that will be 5 factorial over. Now 0 factorial is actually 1. 5 minus 0 is 5. So this will give us 5 factorial can cancel out. So we have 1 over 0, and any number divided by 0 is 1. So we have our value for 5 combination 0. Then we can move ahead to evaluate 5 combination 1. Here we have 5 factorial over 1 factorial multiplied by 5 minus 1 factorial. If you want to express this, when we say factorial, it means multiply by the descending numbers up till 1. So we have 5 times 4 times 3 times 2 times 1. But I know that 4 factorial will cancel out, so I can stop at 4 factorial, all divided by 1 factorial. 5 minus 1 is 4 factorial. So my 4 factorials will cancel out, and this will be 5 divided by 1, which is 1. As interesting as evaluating these combination expressions can be, there is also another method that we can use, and it is referred to as the Pascal's triangle. Now, the Pascal's triangle is taking the powers of, like the expression we're having, a plus b, starting from 2, is taking the power of the expression a plus b. Let's say when the degree is 1, of course, we have that is only a and b. The coefficient of a is 1, the coefficient of b is 1. Now, when the degree is 2, what we do is we add these two ones, 1 plus 1 is 2, then we put the ones at the edges. And continue like that, we'll have 1 plus 2 is 3, 2 plus 1 is 3, 1 at the edges, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and the 1 at the edges, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5 with the 1s at the edges. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and 1 at the edge. Now, these correspond to the coefficient of our variables in increasing powers of n. So when the degree is 2, 3, when the degree is 4, these are the coefficients, and when the degree is 5, which we are concerned about here, these are the coefficients, meaning that each of these coefficients corresponds to our n combination R. So, like for the first one, 1 is 5 combination 0, 5 combination 1 is 5, 5 combination 2 is 10, 5 combination 3 is also 10, 5 combination 4 is 5, and 5 combination 5 is 1. So, from our question, we can say we want to be evaluating the values of the combinations, but knowing Pascal's triangle, I can easily plug in the value of the coefficient of the two entries that we are trying to find the binomial expansion. So, for this power 5, we have 1, 5, 10, 10, 5, and 1 as the coefficient of the values. So here we have 1 multiplied by 2 raised to power 5 multiplied by minus x over 2 raised to power 0 plus, now the next coefficient is 5, so I have 5, 2 raised to power 4, reducing the power now, minus x over 2 raised to power 1, increasing the power of that second entry, plus the next coefficient is 10 multiplied by 2 raised to power 3 minus x over 2 raised to power 2 plus 10 multiplied by 2 raised to power 2 multiplied by minus x over 2 raised to power 3. You can notice the increasing powers of x minus x over 2 and the reducing powers of 2. So now the next entry is 5 multiplied by 2 raised to power 1 now, multiplied by minus x over 2 raised to power 4. Then the last entry is 1 multiplied by 2 raised to power 0 minus x over 2 raised to power 5. And with that, so this is the binomial expansion of the expression we are asked to find. And if you are to go ahead to work this out, 2 raised to power 5 is 32. Any number raised to power 0 is 1. So we have plus 5. 2 raised to power 4 is 16. Now, when we raise the negative power to an odd number, it will always be negative. So it will be minus x over 2. And if you cut, 2 can go in 16. The next variable, 10 multiplied by 2 raised to power 3 is 8. Now, when we raise a negative number to an even power, that will be positive. So I have x squared over 2 raised to power 2 is 4. We can also cut 4 in 8 is 2. Then plus 10, 2 raised to power 2 is 4. Again, we are raising a negative number to an odd number. That will be minus x raised to power 3. Then 2 raised to power 3 is 8. So 4 can go in 8. 4 here 1, 4 here 2. 2 can go in 10, 2 here 1, 2 here 5. Then the next time plus 5 multiplied by 2. Now this will be x raised to power 4 over 2 raised to power 4 is 16. 2 can cut 16. We have 8. Then plus 2 raised to power 0 is 1. But we are having minus x over 2 raised to power 5. That will be minus x over 5. Minus x raised to power 5 divided by 32, because 2 raised to power 5 is 32. So we have to multiply out this expression that we now have. What we are going to get is 32 plus 5 times 8 is 40. But we have minus x, so minus 40x, multiplying that 40. Then plus 10 times 2 is 20, and our x squared. Now we have minus 5s cubed, because 5 times minus s cubed is minus 5s cubed. The next time will be positive. This will be plus 5 over 8 multiplied by x raised to power 4. Then minus x raised to power 5 divided by 32. And our question had been solved in ascending powers of x. We have been able to evaluate 2 minus x over 2 raised to power 5 in ascending power of x from 0, 1, 2, 3, 4, and 5. And that is solution to our A question. Note, we are to find the expression 1.99 raised to power 5. Now, what we need to note is that to use the previous binomial expansion that we are given, we need to express 1.99 as 2 entries that we are subtracting one from the other raised to power 5. And we are to express that 1.99 can be expressed as 2 minus 0.01 raised to power 5. 2. So now if we are to compare this with 2 minus x over 2 raised to power 5, we will notice that, of course, the first entry is 2, but then the second entry is minus 0.01 and minus x over 2, meaning that 0.01 is equal to x over 2, and our x will be 0.01 multiplied by 2, which is 0.02. Now, without expressing this like this, the student will just take the value of 0.01 and plug in into the expression we had before, and that will be quite wrong. It's not 0.01, it's 0.02. So 1.99 raised to power 5. Now, where we find x in our expression that we got before, we just need to plug in the value of 0.02. So we are going to be having, the first entry is 32 minus 40 multiplied by 0.02 plus 20 multiplied by 0.02 raised to power 2 minus 5 multiplied by 0.02 raised to power 3 plus 5 over 8 now, the next entry, plus 5 over 8 multiplied by 0.02 raised to power 4 minus 0.02 raised to power 5 divided by 32. Now, for the observant students, the higher powers of 0.02 will tend to give us quite negligible numbers. But let's also bring in our calculator to see what we are going to get with these values that we are trying to plug in. So here, we have 32 minus 40 multiplied by 0.02. That will be 0.8. So 32 minus 0.8 plus 20 multiplied by 0.02 raised to power 2. That will be 8 times 10 raised to power minus 3. 8 times 10 raised to power minus 3 minus, now, 5 multiplied by 0.02 raised to power 3. That will be 4 times 10 raised to power minus 5. Now you can see that with subsequent values we are getting a large decimal place, and that will be quite negligible. The next entry, 5 divided by 8 multiplied by 0.02 raised to power 3 is raised to power 4. That will be 1 times 10 raised to power minus 7. Now minus 0.02 raised to power 5 divided by, no. We are not dividing the power. We are bringing it down. This whole divided by 32. Okay? That will be 1 multiplied by 10 raised to power minus 10. 1 multiplied by 10 raised to power minus 10. Now, if you are to evaluate this and add up all this together, let's use our calculator also. If you are to add all this and express them in 2 decimal places, actually we will see that we'll have 32 minus 0.8 exponent 8, that's 8 exponent minus 3 Let's this exponent expression. Eight exponent, okay, minus 3. No, we have to bring 4 down. Minus 3, 4, okay. Minus 4 times 10 raised to power minus 3 and minus 5, 0, 0. We can neglect the other ones because they'll be quite negligible. It will be just dot 0, 0, 0, 0, 0, 0 in 7 places, in 10 places. That is quite negligible. So if we sum everything, we are going to have 31.20796, and correct to 2 decimal places will be 31.21 as our answer. Now, just to be on the safe side, we can quickly check with our calculator what is 1.99 raised to power 5. That's 31.207961, and you can see that we're on the right track. That is the solution to our question number 11A. So now, question number 11B, we are told that the polynomial that is given as s raised to power 3 plus q square plus rx plus 9 with p and r as constants, ask s plus 1 as a factor, and the remainder minus 17 when divided by x plus 2. We have to find q and r. Now, we are going to be using factor and remainder theorem, and the factor theorem states that if x plus 1 is a factor, then the function of minus 1 is going to be 0. And if there is a remainder, in this case, minus 17, if you have, say, minus 17 as a remainder, when we are dividing our polynomial by, in this case, x plus 2, then the function of minus 2 is equal to minus 17. Now, what you need to note, when we say x plus 1, when we factor, that means x plus 1 is 0, x is equal to minus 1. We find the function of minus 1. And when we say x plus 2 is used to divide the polynomial, that means when x is minus 2, like x plus 2 is 0, then x is minus 2. Function of minus 2 will give that remainder. These are the remainder and the factor theorems. And using this, we will see how we can solve this our question. So, let's go ahead and plug the value of minus 1 and minus 2 into our polynomial and see what we are going to get from there. So, function of minus 1 will yield minus 1 raised to power 3 plus q multiplied by minus 1 raised to power 2 plus r multiplied by minus 1 plus 9, and we're saying it's going to be 0. So, if you are to express this, in a negative number raised to power 3 will be negative, because 3 is an odd number. So we have minus 1. Minus 1 square is 1. 1 times q is q. R multiplied by minus 1 is minus r, plus 9 is 0. So we have q minus r is equal to minus 8, because minus 1 plus 9 is 8. When it crosses to the other side, is minus 8. We have equation 1. Then function of minus 2, let's use minus 2 in the expression. Minus 2 raised to power 3 plus q multiplied by minus 2 raised to power 2 plus r multiplied by minus 2 plus 9 is now going to be our remainder, minus 17. And that will give us minus 8 plus 4q, because minus 2 raised to power 2 is 4. 4q minus 2r plus 9 is equal to minus 17. So here we are having 4q minus 2r minus 8 plus 9 is 1. When 1 moves to the other side, it will become minus 1, minus 17, minus 1, we have minus 18. So this, I can divide all through by 2, so that I have 2q minus r is equal to minus 9. So this is my second equation, equation 2. All I need to now do to resolve this question is to find the solution to these two equations, these two simultaneous equations, and then my answer is out. So if I want to write out this, I can clear my board. I have q minus r is minus 8 and 2q minus r is minus 9. I can use any method. Let me say from equation 1, I will say that now I can get my q to be minus 8 plus r. And if I'm to use that new equation in equation 2, if I'm to use q is equation minus 8 plus r in equation 2, I will have 2 into minus 8 plus r minus r is equal to minus 9. 2 times minus 8 is minus 16, plus 2 times r is 2r, minus r is equal to minus 9. So, because 2r minus r is r, when minus 16 moves to the other side, that will be plus 16. R will be minus 9 plus 16, and that will give 7. So, the value of r is 7. And then if I want to use the value of r in q, in the expression for q, I can also find q, because my q is equal to minus 8 plus r. That means q is minus 8 plus 7. And that means q is minus 1. So the values of q and r that we are asked to find is that q is minus 1 and r is equal to 7. So here, question number 12 from WAEC Further Maths 2018 May-June exam. We're given these statistics of the 10 coins that were tossed, the number of times, and the outcomes that we have. And we're asked to calculate the mean number of heads, probability of getting an even number of heads, and the probability of getting an odd number of heads. Now, we know that mean is sigma fx divided by sigma f. That is the sum of the product of the frequency and the particular statistics, here the number of heads, divided by the sum of the frequency. So if you are to draw our table to get the value of the number of heads multiplied by the frequency, our number of heads will be denoting that with x and the frequency with f. So if we populate with the information that we are given is the question, we can go ahead to find the value of fx. 0 multiplied by 2 is 0. 1 times 7 is 7. 2 times 23, 46. 3 times 36 will be 108. 4 times 11 is 44. 5 times 61 is 305. 6 times 100 is 600. 7 times 12 is 84. 8 times 8 is 64. 9 times 5 is 45. And 10 times 3 is 30. So we can go ahead to find the sum of our frequency and the sum of fx. Now, summing that, let's bring in our calculator so that we don't make any mistake. Let's bring in our calculator. We want to sum the frequency and fx. So we have, for the frequency, we are going to be having 2 plus 7 plus 23 plus 36 plus 11 plus 61 plus 100 plus 12 plus 8 plus 5 and plus 3. So the sum of the frequency is 268. Is 268. Then we want to sum fx. We want to sum the product of the frequency and our data. We have 0 plus 7 plus 46 plus 108 plus 44 plus 305 plus 600 plus 84 plus 64 plus 45 plus 30. Okay, that's 1,333. 1333. So, using this information that we got from our table, we can find our mean to be 1,333 divided by 268. And if we divide that, our mean, the mean number of heads will be 1333 divided by 268. And that is 4.973888. Now that line is telling us that it's a continuous loop, just like you are dividing 3 over 10. You know, you have dot 33333. So this is a continuous loop, and we can put in our value. But in our question, we're asked to find it correct to 3 decimal places, so we can just stop at 4.974. Okay, good. So here, if you want to find the probability of getting an even number of heads, now, what is the definition of the probability? Generally, probability we can define as the number of our desired outcomes, the number of the possible desired outcomes, all divided by the number of the total possible outcomes. Probability can be defined as the number of our desired outcome divided by the total possible outcome. And now, our desired outcome from this particular question, we are looking for the even number of heads. The even number of heads. We need to know that so that we can identify them appropriately. And then since we have the frequency, we actually add all those frequencies and divide by the total frequencies. So here, to identify our even heads, we have 0, 2, 4, 6, 8, and 10. These are numbers that can be divided by 2 without having any remainder, and 0 is included. So the probability of the even numbers, even number of heads we are looking for, will be 2 plus 23, picking the frequency of the even numbers, plus 11, plus 100, plus 8, plus 3. All divided by the total number of frequencies here, which is 268. And if we add that, we can bring in our calculator to add this. We have 2 plus 23 plus 11 plus 100 plus 8 and 1 plus 3. So that will give us 147. We have 147 divided by 268. If we divide that with our calculator, that will give us 0.54851, 0.5485. But now we're asked to get our answer correct to 3 decimal places. So that will give us 0.549, because 5 will round up to 1 and we add that to 8 and our answer is out. Okay. And now finally from this question number 12, we're asked to find the probability of getting an odd number of heads. So the probability of the odd, if you also identify the odd numbers, since we identified the issue of the even numbers, we'll have this as the frequency of the odd numbers, frequency of getting the odd head, all divided by the total frequencies. Now, the odd heads, if you are going to identify them, we have 1, 3, 5, 7, and 9. So if you add the frequencies of these, that will be 7 plus 36 plus 61 plus 12 plus 5, all divided by 268. So to add that in our calculator, we have 7 plus 36 plus 61 plus 12 plus 5. And that is 121. So we have this to be 121 divided by 268. If we divide that again using our calculator, we are going to get 0.45149, 0.45149, and rounding it up to 3 decimal places, we are going to get this as 0.451. Now, What the student needs to know is that at least we are able to identify that 0 is an even number. And with that, we can always move ahead to solve our questions. Question number 13, we are given the probability of Ali, Baba, and Katie gaining admission to their college. And then we have to find the probability that only Katie and Baba will gain admission, none of them will gain admission, or at most 2 of them will gain admission. Now, if you want to take all these statistics that we are given, and starting with Ali, we are given that the probability that Ali will gain admission, if you call it PA, that will be 2/3 as given. That implies that the probability that Ali will not gain admission, we have been given the probability that he will gain admission, that is 2/3. That means that inherently the probability that Ali will not gain admission will be 1 minus probability that he will gain admission. And that will be given as P prime A will be 1 minus 2/3, and that is 1/3. Subsequently, we can also find the same expression for the case of Baba and the case of Katie. So the probability that Baba will gain admission, if we also call that, let's say we are using the first letter of the name, probability of B, that will be 3/4. Therefore, the probability that Baba will not gain, P prime B, will be 1 minus 3/4, and that will be 1/4. So moving on to Katie, we can also find this expression for Katie. We've been given that the probability that Katie will gain admission had been given for us as 4/5. So we can write it out that probability that Katie will gain admission will be probability of K, which is 4/5. So the probability that Katie will not gain admission, P prime K, will be 1 minus 4/5. And that will be 1/5. So having this, we can now go ahead to solve the 3 questions that we are asked in this probability question. And the first one is saying that what is the probability that only Katie and Baba will gain admission? Now, we need to interpret this question correctly so that we don't miss it. We are being asked the probability that only Katie and Baba will gain admission. Now, we have 3 personalities that we are talking about, but we are being told that it's only Katie and Baba that will gain. That will imply that Katie will gain admission, Baba will gain admission, but Ali will not gain admission. You know, there are 3 of them. We have Katie, Baba, and Ali. So we are looking for the probability that only Katie and Baba will gain. That means that Katie will gain admission, and at the same time, Baba will gain admission, and also at the same time, Ali will not gain admission. So this implies that Katie gains, Baba gains, and Ali did not gain. And since we found the expression of these probabilities, we can input our value, and in the case of hand, we use multiplication. So Katie gains is probability of K, which is 4/5. Baba gains is probability of B, which is 3/4. Then Ali fails is P prime A, which is 1/3. Now dividing, we can cut 3 out, can cut, and 4 can also cut. This will leave us with 1/5. So the probability that only Katie and Baba will gain admission is 1 divided by 5. Now, I want to look at the probability that none of them will gain admission. The probability that none of these 3 personalities we are looking at will gain admission. Now, that will mean that Baba fails, Ali fails, and Katie fails. And that will be P prime A multiplied by P prime B multiplied by P prime K. These are the probabilities that each one of them will fail. So none pass means that each one of them fails, and that will be 1/3 multiplied by 1/4 multiplied by 1/5. And if you multiply that, 3 times 4 is 12, 12 times 5 is 60. We have 1 over 60. Okay, good. And now, on the last note, we want to find the probability that at most 2 of them will gain admission. Now, this is quite interesting for me. What is coming to mind? What can we interpret with this statement that at most 2 of them will gain admission? I want to encourage students out there that you need to work smart. When you are listening and you are hearing the word at most, you are reading, you are seeing at most, what interpretation comes to mind? Now, the danger is that you want to start writing out all the possible probabilities that will culminate in at most 2 of them gaining admission. But we need to work smart. So, if you want to work smart, what do we need to do? Now, inversely, if you are being told that at most 2 of them will gain admission, the only exclusion to that case in all of the possible outcomes is that all of them will not gain the admission. So, this question that we are being told that at most 2 of them will gain admission, it will involve all the possible cases except when the 3 of them gains admission. So, we can look at all the combinations that maybe Ali gains, Baba gains, Katie fails, Ali fails, Baba gains, Katie gains, Ali gains, Baba gains. You know, all those on. But no. You don't need to stress yourself like that. This is going to be all possible cases except when the 3 of them gain admission. And that will be 1, which is all possible cases, minus the scenario in which all of them gains, which is probability of Ali multiplied by probability of Baba multiplied by probability of Katie. I hope the student out there can get to grasp this and understand it. So this will be 1 minus probability of Ali is 2 over 3. Probability of Baba is 3 over 4. Probability of Katie is 4 over 5. And if you are to divide and cut out, 3 will cut out, 4 will cut out. So we have this to be 1 minus 2 over 5. And that is equal to 3 over 5. Wow. Good. So what I want to encourage students is, whenever we are working with questions like this, don't just rush in to try and doing the possible outcomes. First, interpret the question well, and you can easily get your answer smartly. So here in our question, we are given the position vectors of points A, B, and C, and then we are told that A, B, C, and now another new point, N, they all constitute a parallelogram. We have to find the position vector of N. We have to find the magnitude of AN and the magnitude of vector AB. Then we have to find the acute angle between vector AN and vector AB. Now, a good overview of our vectors before we go ahead to launch into this video. Normally, when we are talking about vectors, we are talking about a quantity that has both direction and magnitude. So, if you are to draw our vector components, component I and component J, now let's take that. Let's assume that we are looking at 2 position vectors A and B. For us to get to A, we can actually go through directly from the origin. You can go from the origin to A. Can go from the origin to A, and let's call that vector A, small letter A. We can also go from the origin to B. Let's call that vector B, small letter b. Then, of course, we can also move from the point capital A to point capital B. Okay. Let's call that's another vector. That's vector AB. Now, looking at point B, if you want to navigate from the origin, there are 2 paths that we can actually go through. Is either we go through first the small letter A, then from the capital letter A to the capital letter B, or we go directly from the origin and go through small letter b. That means that to get to point B, we can go through A plus AB, or we can go through B. And meaning that our AB will be B minus A. Now, this will help us a lot in trying to work with our vectors, that vector AB is position vector of B minus the position vector A. This will help us to actually solve our question. So having this understanding, let's go ahead and try and estimate what we can get with the question we are being asked. So if I have my graph here calibrated in two units, I can represent all the points A, B, C that have been given in the question. So now A is 8i and minus 10j. So taking that in two units, 8 will be in 4 places, minus 10 in 5 places. So I have A as 8i minus 10j. I can go ahead to locate my B. B is 2i plus 6j. So 2i, 2 and 6j, 3 places, okay? That will be B, point B, 2i plus 6j. Then let me also go ahead to locate the point C, minus 10i. Minus 10i will be to the left, and then 4j will be on the upper part. So I have my C to be minus 10i plus 4j. Now, we are told that if we include another point N, we are going to have a parallelogram. Now, a parallelogram, by our understanding, is a shape that has both of its two sides parallel to one another. So, if we are to join these points that we have already, point A, B, C, if you are to join these points A, B, and C, we can go ahead to say we want to find another point N that will be parallel to these two lines that are being drawn in green. Now, these are two sides of the parallelogram. The other two sides are going to be parallel to each of these sides. So we have another side will be parallel to CB, and then another side will be parallel to AB. Now, just by looking at the symmetry of this diagram, we can see that the distance between point B and C, looking vertically, is only 2, and then the offset between B and C, looking horizontally, that will be 12. That will be 12. So this displacement 2 and 12, we can also replicate at the base of the diagram. So from A, we replicate a distance of 2 units down the graph, and then from A also, we can replicate a distance of 12 units to the left of A, and that will give us the point N as an estimate of what we are trying to get. So now, doing that, I can actually draw my parallelogram and complete my diagram like this. Now, this is point N that I am asked to find. I'm using this as a guide so that whenever I'm working, I can know that this is the estimate of what I want to get. And if you look critically, this point N will correspond to minus 4i minus 12j. I don't think WAEC will accept this as a means of working for us, but actually this is correct. We are going to work it out mathematically, not on the graph. And if you see, our parallelogram is out already, and I have an idea of what my position vector N is going to be. So having this understanding, I can go ahead to work, but then there is a rule of thumb for me to know. If I can get my N, I can also get the angle theta between vector AN and vector AB as shown in the diagram. Now, another point for me to know, if I'm talking about, in the question B, they are talking about AN and AB. Okay, now from this diagram, vector AB and vector NC, they are actually equal. Now, the magnitude is equal and the directions are equal. And AB will be B minus A, and NC will be C minus N. From the first postulate we are trying to clarify in our work here in this video. Or we can also use vector AN, which is also parallel to vector BC. So vector AN is also equal to BC. They are parallel, they are equal in magnitude, they are going in the same direction, and so those two vectors are equal. We can use either of these two expressions, b minus a is equal to c minus n, or n minus a is equal to c minus b, to find the value of our n. So with this, as a basic understanding of how to work with our vectors, we can go ahead to question number A. So in question number A, we are asked to find the position vector of n, and n is a point that renders our parallelogram to be complete. So already we have A, B, and C. Then we are looking for the fourth point n that will render our shape to be our parallelogram. And like I explained before, vector AB is the same as vector NC, and alternatively I can say vector BC is also equal to vector AN. Now, because these constitute a parallelogram, you can pick any of these two and work with it to get the value of the position vector of n. Now I'm going to take vector AB is equal to vector NC, but for my n, I need to also define its components. Y, let's say I take vector n as xi plus yj, meaning that my n is equal to xi plus yj. So now I can find the value of AB, which will be b minus a, and nc, which is going to be c minus n, component wise. So going to that component wise, I can now say my AB, vector AB, I want to use vector AB and equate it to vector NC. So I can say that means that the position vector b minus a is equal to the position vector c minus n. B is 2i plus 6j, a is 8i minus 10j, c is minus 10i plus 4j, n is xi plus yj. So I can go ahead to plug in all this. I have 2i plus 6j minus a is 8i minus 10j. This is equal to my c is minus 10i plus 4j, and n is xi plus yj. Okay, good. Now I can open up the bracket and collect like terms and bring the I components together, bring the j components together. So I have 2i minus 8i plus 6j minus 10j. This is equal to minus 10i minus xi plus 4j minus yj. Now 2i minus 8i will give me minus 6i. 6j minus 10j will give me plus 16j, because the negative signs will multiply each other to be plus. Minus 10i minus xi will give me minus 10 minus x all into I. Then the other will give me, that will give me 4 minus y all into j. And now looking at the left hand side and the right hand side, I can equate the components of I and also equate the components of j. If I want to collect the like terms for the component I, that means that minus 6 is equal to minus 10 minus x. And for the component j, that means 16 is equal to 4 minus y. So looking at the I component, minus 6 is equal to minus 10 minus x. And then if I'm to solve for x will be minus 10 plus 6, and that will be minus 4. And also for the y component, I will have 16 is equal to 4 minus y, so that my y will be 4 minus 16, and that is minus 12. So since I've defined my n as xi plus yj, that means the value of my n is coming out from here. I can say my n is equal to minus 4i minus 12j. And like that, I've been able to get the position vector of n that constitutes our diagram to be a parallelogram. Okay. So now we are asked to find the magnitude of the vector an and the magnitude of the vector ab. Now, how do you go about finding the magnitude? Knowing that initially we are only given the position vectors, but now we are being told to find the magnitude of the vector an. How do we express the vector an? Again, like I explained before, an will be the position vector n minus the position vector a. So an first is n minus a. So now we have n, we just evaluated the value of n to be minus 4i minus 12j. And then we have a, we are given a in our question to be 8i minus 10j. So if you are to open up this bracket, that will be minus 4i minus 8i, then minus 12j minus 10j. Now, the student should not forget all those signs. This will now constitute minus 12i. The negative will multiply each other to be plus. So we have minus 12j plus 10j, and that will be minus 2j. This is vector an. And now the magnitude of an will be, the magnitude is just something similar to the hypotenuse of a right angle triangle, and that will be the square, the sum of the square of the components will find the square root, and that will be square root of 144 plus 4, which will be square root of 148. So similarly, we can also go ahead to find the magnitude of the vector ab. Just as we did for vector an, we can go ahead to say vector ab. To find its magnitude, first we need to find an expression for vector ab, and that will be position vector b minus position vector a. We are giving b to be 2i plus 6j, so that will be 2i plus 6j, minus, we are giving a to be 8i minus 10j. So going ahead to open the bracket, that will be 2i minus 8i plus 6j minus 10j. Don't forget the negative sign. Alright, so this will be 2i minus 8i will be minus 6i. Minus 6i. Then 6j will be plus 10j, which is plus 16j. And from here we can go ahead to find the magnitude of the vector ab, and that will be square root of minus 6 square plus 16 square. That will be square root of 36 plus 16 is 256. So we have that as the square root of 92. Yes, so that's the magnitude of vector ab. Now, we are through with our question B. We can now go ahead to say we want to find the acute angle between AN and AB. To find the acute angle between vector AN and vector AB, how do we go about that? The dot product of vectors is the tool that we can use to determine the angle between two vectors, and what is the expression of the dot product of vectors. The dot product of vectors is telling us that we can find an expression for the dot product by saying, let's say we want to consider vector AN and vector AB, as in the case in this question, then the dot product will be vector AN dot vector AB is equal to the magnitude of vector AN multiplied by the magnitude of vector AB multiplied by the cosine of the angle between the two of them, cos theta. Now, this is actually an offshoot of the parallelogram law of vectors, or the parallelogram law generally. And from here, we can say that cos theta is AN dot AB all divided by the magnitude of AN multiplied by the magnitude of AB. Now, remember, we have gotten the magnitude of AN and the magnitude of AB. So if we are to bring in our vectors, that will be minus 12i minus 2j multiplied by AB. AB is, we have gotten it initially in question B, minus 6i plus 16j, all divided by the magnitudes that we got initially, square root of 148 multiplied by the square root of 292. So now, how do we find this dot product on the numerator? What we do is we take the components, like the I component, we multiply them together, plus the j components, we also multiply them together. So going ahead with that, we can have our cos theta to be equal to, now we have the I component minus 12 multiplied by minus 6 plus the j component minus 2 multiplied by 16, all divided by square root of 148 times square root of 292. Now, minus 12 times minus 6, the negative will become plus, so we have 72. Minus 2 times 16 will be minus 32, divided by 148 multiplied by 292. 72 minus 32 will be 40, and we have 40 over square root of 148 times square root of 292. Let's bring in our calculator here and try and find this expression. So we have 40 divided by square root of 148 multiplied by square root of 292. That is equal to 0.19241. Okay, that's 0.19241. Now that is cos theta. That is cos theta. So our theta will be arc cos 0.19241. So we can also bring in our calculator to find that expression. Arc cos, our answer, that will be 78.90627. So we have this as 78.906. So, but we are asked to find our answer correct to 2 decimal places. That will be 6 we round up to 1. We add 1 to 0. That will be 78.91 degrees. So that is the angle of that's the value of the acute angle between vectors AN and vector AB. So here we have this question number 15. A uniform beam XY, which is 4 meters long and weighing 315 Newton, rests on 2 pivots P and Q, and it is kept in equilibrium by weight of 80 Newton and 1000 Newton attached at some point. Then we are to calculate the reactions at point P and Q, and then if the weight is the 1000 Newton weight is replaced with 1200 Newton weight, at what point from Q should it be placed to maintain equilibrium? Now, interpreting this question will help us a lot to try and solve it. So, if you have our uniform beam XY, now his own weight will act at the middle, at the center of the beam, because we are told that it's a uniform beam. So, the weight will be evenly distributed, and we can take it at the center, that's 350 newtons. Then, we're also told that it is kept in equilibrium by another weight of 80 Newton, which is at point X. So if you go to point X, here we have 80 Newton weight being placed there. Then there's another 1000 Newton attached at a point between P and Q, such that it is 0.6 meters from Q. Now we are told that XP, okay, we have pivots at P, and we have been given XP to be 0.8 meter. Now, between X and 350 Newton, there is 2 meters because the whole meter is 4. The whole beam is 4 meters. So, here between X and P, we are going to have 0.8 meters. And then, so let's label that as this is 0.8 meters between X and P, 0.8. Then we know that if that is 0.8 and half of the beam will be 2 meters, that means between P and the center of the beam we have 1.2 meters. But we are told that PQ, the two pivots PQ, are spaced 2.2 meters afar. Now we have taken 1.2 meters between P and the center of the beam. Then this other distance between the center of the beam and the point Q will be 1 meter, so that 1 and 1.2 will amount to 2.2 meters as we are given. Okay. Now, doing all this will actually help us seriously. And furthermore, we are told that the 1000 Newton is placed 0.6 meters from Q. Okay, so from Q, what we need to measure is some 0.6 meters, and then we can put in our 1000 Newton weight. So our 1000 Newton weight will be somewhere around here. All right. So now, interpreting the question like this had helped us a lot in solving for the distance that we are going to be finding our product of momentum from, so that now, once we have all this, at the pivots, there will normally be some reactions. There will be a reaction at P, there will be another reaction at Q. And we can check for the distance between all this. Now, we've been told that P and Q is 2.2 meters. All right. So, if we are to go ahead to try and complete our diagram by noting the reaction at P, let's call that RP, and the reaction at Q, let's call that RQ. Two principles are going to be guiding us, and this will help us in solving our question easily. Now, the first principle is that the sum of the clockwise moment is equal to the sum of the anti-clockwise or counterclockwise moment. So, if you are summing clockwise moment being denoted like CW clockwise and the counterclockwise CCW, the sum of those moments are going to be the same. Then for equilibrium, the sum of the upward forces is also going to be equal to the sum of the downward forces. Here we are seeing that some forces are going down, the 80 Newton, 350 and 1000 Newton, while we have some reactions at pivot P and Q. Those are the upward forces. So, using these two principles, our questions will be easily solvable whenever we apply these principles. So, we can go ahead to try and find the solution to question number A. So now, we can go ahead to solve our question number A, in which we are asked to get the reactions at point P and Q. So now, from the diagram as indicated, we have RP and RQ as the reactions at these 2 points P and Q. So if we are to take the moment about point, let's say point P, we can find the clockwise moment and then the counterclockwise moment, and equating them, we'll be able to solve for one of these reactions. So now, looking at point P, if we want to find the moment about point P, we should recollect that the formula for finding the moment is force is the product of force multiplied by the perpendicular distance in which the force is acting upon. Not just the distance, it's the perpendicular distance. So here, you can look the moment using the principle of counterclockwise moment is equal to the clockwise moment, we can look for our clockwise and counterclockwise moment. Our 80 Newton will be a counterclockwise moment around P. 350 and 1000 Newton weight will be clockwise moment around P. Then the reaction at RQ will be a clockwise moment. There won't be any reaction at P because that's the point where we are taking our moment from. So summing these clockwise and anti-clockwise moments, we can equate them together to try and see how we can solve for, in this case, the reaction at Q. For our clockwise moment, the distance is 2.2 for RQ plus 80 times the distance between that 80 Newton force and P is 0.8. This will be equal to our 350 weight multiplied by the distance between 350 and P, which is 1.2, plus our 1000 Newton weight multiplied by the distance between that weight and point P, and that will be 2.2 minus 0.6. So that will be 1.6. 1.6. So now that is telling us that 2.2 multiplied by RQ will be, now bringing our calculator, we have 350 times 1.2 plus 1000, that 1000 times 1.6 is 1600, minus, when the 80 multiplied by 0.8 move to the other side, they will become minus 80 times 0.8. This will give 1956. Okay, 1956, such that our RQ will be 1956 divided by 2.2. So divided by 2.2. This will be 889.09 newtons. 889.09 newtons. So that is the reaction at point Q. Now, for us to get the reaction at point P, instead of going all the way and taking the moment around point Q now, we can just use the other principle, the sum of the upward forces and the sum of the downward forces. So RP plus RQ, which are the upward forces, if we sum them, they're also going to be equal to 80 plus 350 plus 1000 newtons, which are the downward forces. Now we have gotten our RQ already. So RP will be 80 plus 350 is 430 plus 1000 is 1430. But I want to write that out, minus RQ. RQ is now 889.09 newtons. So this will be, let me bring in my calculator again. Okay, 80 plus 350 plus 1000 minus 889.09, 540.91. So reaction at P is 540.91 newtons. And with that, we have been able to solve question A. Now, for us to solve this question number B, in which the 1000 Newton weight is being replaced with a 1200 Newton weight, and we have to find the distance from Q where that force will be placed. Now we have our 1200 Newton weight being included, and we are looking for the distance between this and Q, which you can tag as X, and then we have to find the value of X. Now, what we need to note, which students will generally make a mistake of, is to think that the reaction at point P and the reaction at point Q, they are still going to be the values that we got in question A. But no, that would be quite wrong. Because we are changing the value of the 1000 Newton, that means that the reaction at P and the reaction at Q, they will also change. So RP and RQ will change, since the 1200 Newton is now replacing the 1000 Newton that we are using before. Now, if you look at the question, it will look as if the information we have is not sufficient for us to calculate the distance as being requested. That means we are going to leave our question in the form of RP and RX. So if you bring in our direction of moment, now we want to take moment about point Q, which will be the one that will be suitable for us to get distance X. We take the moment about point Q. Okay, let's find the moment of all the forces operating at point Q. We can't use the previous ones, so we can erase our moment. Let's erase this. Now, this direction now, in this case, at point Q, the 350 Newton will go in the counterclockwise, and the same with the 1200 Newton, but the reaction at P will go in the clockwise direction. The distance between P and Q now will be 2.2, which will be the distance for RP. Then we know the distance for 350 Newton. We don't know the distance only for the 1200 Newton width. So this will be counterclockwise, 1000 Newton counterclockwise. Then the reaction at P is the only clockwise moment. So taking our clockwise moment, 2.2 multiplied by RP will be now 80 multiplied by the distance between 80 and Q is 3, 0.8 plus 2.2, then plus 350 multiplied by its distance to Q, that will be 1, because we have 2.2 minus 1.2, that will be 1, then plus the 1200 Newton multiplied by the distance we are looking for, which is X. So with this, you can easily say that our 1200x will be 2.2 RP minus 80 times 3 is 240. Then 350 times 1 is 350. So that will give us 2.2 RP minus 590. Okay, if we divide through by 1200, our x will be 2.2 RP minus 590 divided by 1200. That will be the solution to our question. Don't forget, it is that we are not using the value of RP that we got in the previous question A. Now the reaction will change and we don't have enough information to evaluate that, so we leave it as RP. And that is the solution to our question number 15 from WAEC May June 2018 further maths theory paper. And with that, we have come to the end of treating our questions from further maths 2018 past question. Now, the journey has been quite long, but for you to have seen this through to the end is showing that you are giving what it takes for you to gain academic excellence in your exams. And from the very depth of our heart, we are wishing you the very best of luck as you go prepare like this. Somebody once said, proper planning prevents poor performance. And this is an attestation to the fact that you want to be prepared, and not only prepared, you also want to aim for the very best that is possible for you. And so that's what we are going to be having today. And what we want to advocate for is that please go ahead, share this video, let your friends know about it, let your loved ones know about it. You have a younger brother, you have a neighbor that you think is going to need this, share it with them. And with that, all of us can gain academic excellence. It's Davetuts Academy, where we are devoted to building academic excellence in students. And until next time, God bless you.